The influence of heat stress on farm animals, identification and expression of heat stress, and calculation and use of heat stress indexes in practice. So what is heat stress? It occurs when the environment temperature exceeds the thermal neutral zone, the TNZ, disrupting the animal's ability to maintain thermal balance. Heat stress has a huge economic impact. Heat loss programs and technology can cost up to 2.5 billion euros annually. So the effects of heat stress, there are direct effects such as reduced feed intake and productivity, and behavioral changes like seeking shade, lying on wet surfaces, or standing more to reduce heat buildup. Heat stress can cause impaired reproduction, disrupted estrus, and altered embryonic development. It also increases mortality due to physiological strain. Heat stress also has indirect effects, such as lower immunity, increasing vulnerability to infections, and reduced performance and growth efficiency. And there's also a higher risk of metabolic disorders, such as acidosis in ruminants. For the species-specific impacts, ruminants tolerate the cold better than the heat. They have a wide thermal neutral zone. Milk production will drop 24 to 48 hours after a cow is heat stress. And heat stress also reduces colostrum antibodies in quality in dairy cows. The THI, temperature humidity index, says the threshold is greater than 72, which correlates with reduced milk yield. For pigs, their thermal neutral zone varies by weight and body condition. When pigs are above their thermal neutral zone, pigs will show reduced feed intake, increased water consumption, and behavioral adaptations like lying on wet surfaces. Poultry can have a quick adaptation to heat stress within 5 days. When they have heat stress above 30 degrees Celsius, this reduces their egg production and weight due to impaired calcium metabolism. Poultry will have evaporative cooling by panting, and it's critical, and in hot and humid climates are particularly challenging for poultry. The detection and measurement of heat stress. The indicators are increased respiratory rate, rectal temperature, sweating, and water consumption. The tools we use is the temperature humidity index, the THI. It monitors heat stress impact. The recommended THI for dairy cows is 68. This is when they're producing 35 kilograms of milk a day. If the THI is greater than 72 for over 4 days, it strongly correlates with milk yield loss. And how to decrease heat stress? Have housing improvements, insulate buildings, have ventilation systems and shade provision. And try and manage behavior, minimize overcrowding and provide wet surfaces. And have monitoring systems, have automated climate controllers and negative pressure ventilation.